In this demonstration, you'll learn typical topology building and surface mesh preparation processes in ANSYS fluid meshing. Starting with a CAD file import, the result will be a conformal connected surface mesh. Fluid meshing can use the CAD curvature data instead of the faceting for a more accurate mesh size distribution. Select CFD surface mesh to convert CAD parts to mesh objects. Specify min and max face size, as well as curvature and proximity parameters to produce a size field used for meshing. The size field can be saved. The model consists of 4 pipe objects joined as a T-junction. The Diagnostics tool is capable of detecting and repairing common geometry errors. Specify the type of issue and relevant parameters. For example, a gap smaller than 1/20th the minimum face size should connect without explicitly closing the gap. Mark will identify all found issues. First, zooms and highlights the affected faces and provides links to tools to repair the problem. This is clearly a small gap which can be closed using the Remove Gaps tool. Redraw the area when the issue has been repaired. Use the Next button to step through all regions identified by fluid meshing. Here, the face zones are not parallel. This problem will be fixed by projecting one face zone to the other. Start by separating the 2 zones from their parent objects. Select the first zone and set it as the target. Then select the second zone and project it to the first. Clear all zone selections and redraw the model. Select the existing caps and update their properties to include the appropriate boundary type. The open end of the pipe must be capped to create a closed volume. Use the Capping Surface context menu under Model Construction Geometry. An appropriate name and type are given. The boundary is set by specifying an inside edge on the pipe end. A quick visual shows a good quality surface mesh. The new object is created as a geometry object, which is converted to a mesh object for further processing. To produce conformal meshes across boundaries, all mesh objects must be merged into a single object. Select the default name and change it to something more suitable. The original objects are now represented by face zone labels, which are the link back to the original geometry. Volumetric regions are watertight regions bounded by the object geometries. Cell zones hold the actual volume mesh when it is created. Select all the face zone labels and then select Join Intersect. This step will create a conformal mesh where adjacent face zones meet. Where original CAD bodies meet, the surfaces will be joined. The Mark Faces button is used to highlight those faces affected by the operation. The model is fully remeshed, resulting in an excellent quality surface mesh. Redraw and show all. Use multi-connected face display to show conformal surface mesh where joins occurred. Check the mesh statistics summary and note 0 free or duplicate faces, and maximum skewness is suitable for creating a volume mesh. Save your work with a suitable file name. This concludes the demonstration of surface mesh preparation processes in ANSYS fluid meshing.